Moby is killing your DevOps efforts. Not this guy. Who am I? I'm Kris. I lost count on how many UK UUG FLOSSUK conferences I've been speaking. For the past 10 years, I've been the chief travel, chief trolling, chief whatever officer at Inuits.eu. We're still an open source consultancy company. 10 years ago, I probably said we're like 5 people, now we're 85. And I have this small little hobby where I start conferences. I started DevOps Days about 10 years ago. I started Config Management Camp, Load Days. So if people ask me about DevOps Days, yes, I'm sorry. So today's plan is basically, actually it's worse, because I realized this morning that I was going to reuse 75% of slides from a talk you've already seen from 4 years ago. This one is going to be reusing slides from 8 years ago. But this time it's actually to make a point. DevOps. For a lot of people, we summarize this by what Damon and John came up with after they did a lot of interviews in their podcast, The DevOps Cafe, and they figured out we talk about culture, we talk about automation, we talk about measurement, we talk about sharing. But in short, it's a global movement that is helping to improve the quality of software delivery, leveraging open source tools, and we started it in Ghent back in 2009. This is a 10-year-old slide, because that's a slide I gave together with Patrick at a conference in Antwerp where we had a vampire team, and you'll see those slides again, where we basically were trying to push out the contradictions between developers and operations, and it was pretty bloody. And why are we doing this? Why are we talking about this? It's because in the old days, for most people that's yesterday, things that happened were Friday afternoon, 4 p.m., 5 p.m., here's a tarball, can you put this in production? And we were like, but the dependencies, servers, databases, security, how do I scale this? How do I make this redundant? Where do I put my users? And my computer cannot install this. So 10 days into operations, this is what happens. A train wreck, a crash. Nobody knows what happened, but it stopped working. And we spent 4 or 5 years hosting conferences. Even this building, DevOps Days, was this year, and I think last year also, the Edinburgh edition. And we've been trying to get people to work together, like collaborate, talk to each other. Might be having different roles, but your goal still is together to build software that serves value for your users. And then something happened. A new tool popped up, a new hype. And a lot of us were like, yeah, but I mean, this is Vagrant LXC, but a nice command line. Or there's nothing new to this. We've been doing containers for 10, 15 years. But for some reason, it became quite popular. It was really the new cool thing to do. And we came to the point where people actually gave Ignites at conferences with only one word in their slides, just Docker. That was the talk, the only thing. Obviously, today we need to replace that talk completely because they've rebranded. Have you noticed? Has anybody read the book?
Which book?
Moby, the whale?
Yeah. Yeah.
Is that a happy story? It depends. It depends. It's not really a happy story. It's really an aggressive whale. Some people think I'm actually the aggressive person attacking Docker. That's not the point of this talk. So, let me tell you a couple of history lessons on what we learned over the past 2 decades. I used to be the openMosix release manager. I think actually that's probably one of the first talks I gave at FLOSSUK. Don't even remember where. And what openMosix was, it was a Linux kernel patch which allowed you to split processes in two, and we shipped them off to remote machines, and we orchestrated them so we could share load, and we could say, hey, that machine is not loaded, we're gonna run some compute there and get me the results back. And it was ideal for stuff like short-lived processes and, well, also long-lived processes, because it could take a while. But if the node disappeared, well, we need to do recomplete. We needed to recompletely do all the calculations. And we had a file system in there, kind of. But it had some limitations, and we started working together with developers to work around those limitations. We had some packages like shared memory. How do you use the same memory over different machines? And we tried to fix things by putting in a file system that was available on all the machines, but then you get issues like locking and consistency. So I think my biggest contribution to the Linux kernel at some point was actually removing all the traces of the openMosix file system. So we learned that we needed to work together with developers on figuring out which kind of applications behaved best on that platform, and had to conclude that some applications were just not a good fit. So fast forward. Some years later, I give talks about this too at this conference. Linux HA. How do you make MySQL redundant? How do you make other applications redundant? Well, the whole ecosystem is there. Heartbeat version 2, pacemaker, CoroSync, and what we were doing there was we wrote cluster resources that were monitoring our servers, where we were defining constraints, clones, these locations have to be, these resources have to be running on the same nodes and all that kind of stuff. Does that sound familiar to you? Isn't that what we're doing today also with some kind of tools? 13, 14 years later. And typically those were long-running services, things we didn't want to stop. And again, in that ecosystem, we learned things. A lot of applications have state. They write things on disk. And when something moves to the other side, they expect that file to be still there. But typically it wasn't. So we needed to talk to the developers that wrote the code and figure out, hey, where do you keep your state? How do we do this? Can we work together? People write to a local file system, we need to tell them to write to a shared file system or to a database. And we needed to work together with the developers and say, hey, I want to know how healthy your application is. Because I want to do something if your application fails. And it's not just, I can still open a socket, but I want to have an endpoint where you tell me you're still healthy, or you give me metrics. And we learned, and those were the things we were doing together with developers, helping them understand how the application worked, getting insight in the behavior of the application. So we worked together with them. Applications sometimes needed to be modified. We needed to set up cluster file systems. We needed to update monitoring and change our strategy from, yes, the socket is still open, yes, the socket is still open, yes, the port is listening, to, oh, yes, we actually got a business response which is valuable. And sometimes that didn't work, and sometimes that worked. And what we learned there is that using open source tool, typically this worked better than with proprietary tools. So, who is running on the public cloud in this room? It's starting to become better. That was about 30%. When I asked this question, and I think it was at OCC in Berlin, I don't remember which year, I think 2 or 3 years ago, full room, Brent can tell how many people were in there. There was one hand, and my response back then, hey, that's the American. So things have evolved, but still. Cloud adoption is slow because enterprises are still afraid of cloud for a lot of bogus reasons. And we figured, hey, private clouds will solve this, right? We're going to go to the cloud. We know how to do this. And then the enterprise said, here's a 4-page Word document for each VM you want to provision. So we saw the private cloud fail. We saw people basically taking identical snapshots of what they were building on-prem and moving it to the cloud with all these things. I mean, what is automation? The DevOps movement, it's infrastructure as code, it's automating everything we can. It's improving our monitoring, it's improving our metrics. And these were the failed private cloud deployments. Manual deployments. Our data centers still look like this. It's a cage, nobody has access. IT is the department of, you're not going to go there, because they didn't adapt. IT departments did not adapt. So shadow IT started popping up. And this is where we saw and that was kind of the area when, well, the era when I started getting a lot of people, hey, we're going to use this Docker thing. And one of the best stories there is I got called to a new customer and talked to their CIO, and he was like, yeah, we get a real problem with this Docker thing. Okay. Yeah, because when we reboot it, all our data is gone. Okay. That works as designed. Yeah, but it shouldn't happen. And this is what their Docker infrastructure looked like. This was one container. And I thought this was an exception. This is just the one customer I need to explain this is not how you use containers. Except more came, and it started to become a default. Even up to a point where I was actually giving this talk in Copenhagen in October, November, and the talk after me was somebody from a big 5 consultancy explaining how they were doing this, and they were proud of it. It's a full VM. They have backup tools running inside of it. SSH is a default connection. Who thinks that's what Docker is used for, or supposed to be used for? It isn't. So we realize these kind of things. I mean, people want to change the architecture, and it fails. We just put a monolith in a container, called it a microservice. It's containers, right? We're the hip folks, we're the hipsters now. Or just giving your old legacy tools a nice Swedish name. But it has some advantages, because there's problems we want to solve. There's built environments, and that's the first kind of adoptions where a bunch of ops folks started to use containers. Because we were fed up with this kind of things. How do I build in a contained environment software? I need to install something in the Python ecosystem. Oh, well, you first need to install pip, then easy install, and well, these days, Conda and maybe some other packaging tool, and you end up having a package. But you cannot reproduce it, and you want to build environment each time. So we started using Docker as a packet manager. And this is a 10-year-old slide. What's different between the virtual machines? So where did we end up? I gave a keynote at Mazelscan in Amsterdam 2 years ago. The day after I gave the keynote, I came into a customer, and literally it was a Friday, 10 a.m. in the morning, and some developer came to me and said, here's a container, can you put this in production? That was a customer where we spent the better part of the 2 years before that building pipelines with Jenkins, which we completely automated, building a fully completely automated Puppet infrastructure, and they could basically take any Java application which they had in their catalog and deploy it within a couple of hours to production. It was fully automated. But someone figured to completely ignore what the organization had agreed on and throw a container at us. There was no infrastructure. There was nothing. Okay, I could spin up my kube cluster in 20 minutes because I had it puppetized, but I wasn't allowed to do that because of a lot of things. And exactly the same questions came. So, what database are you using? Just some local files, SQLite. What distribution are you using? What's the distribution? Who's going to do monitoring on this? It's a proof of concept. And the better one is, how did you build this? Oh, here's a Docker file, which we tried to build, which failed because we were behind a firewall in a corporate environment, and it was pulling random stuff from the internet. So this image is how we described the divide between development and operations, and a wall of confusion in between. It used to be small packets, which we threw over the wall. But now we're getting hit with big, fat containers. They hurt even more. So this is what we have. What corporate proxy? Here's a Docker file, and when you eventually build it, oh yes, there's these other two containers. We got a Mongo and we got some queuing system. Oh, so your application starts from Alpine, Mongo starts from I have no clue, and the third one starts from Debian. You do realize this is a RHEL-only shop, right? And security is kind of tied on those folks keep track of what's happening there and not in the rest of the ecosystem. Not because they don't like it, but because they only have 8 hours a day to work on. And it's a small team. And then the guys go like, what do you mean distribution, security updates? So they couldn't rebuild it. They didn't know where the containers were coming from. And the actual question is, why did they even put this in a container? Because it was a stateful application. I'm talking about 2 years ago. And how do you build the host that runs the container? It works on their laptop, and that's about it. So we started talking and explaining people again how we do these things and how these things work. And the ops folks started learning again, as we do for the rest of our lives, learning new stuff. And then the other realization started popping up. This thing really wasn't ready for production. It was unstable. The number of kernel issues I've seen when we first started doing Docker, probably 10 years ago since I saw something that stable. It's improved now. But definitely the first 3 years, it was painful as hell. And even if you see the timestamp on these tweets, it's not a year only old when Igor basically tweeted, how do we fix an application in Docker? Well, where we started. How do we fix a host misbehaving in Docker? We reboot it. I think that's not the mentality us Unix folks have. But the youngsters don't mind. So we end up with this. Some guy builds an image and nobody maintains it. This is the opposite of what the DevOps movement is supposed to preach. Rebuilding things from scratch. I mean, the talk this morning was about reproducible builds. Most of those people can't. They build stuff from the internet, random packages, sometimes even with curl pipe, whatever. What if somebody removes a JavaScript library? That's not happened ever. So if it's a container or not, we still need to make sure that this works. And even if we can, there's going to production. Michael Ducci, who was actually the person who did the Ignite in Amsterdam, saying Docker, 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 Docker for 10 minutes, or 5. He posted this. Like, this is a developer running a container on his machine, and this is the ops guys pushing this thing to production. I mean, Docker, okay, maybe some orchestration, networking. How do we do orchestration and upgrades? How do we monitoring? How do we supervise these things? How do we push changes through? Service discovery, security, the list goes on. So let's go over the list. If you're a developer writing an application and you're doing it in a container, you've got one machine. It's your local laptop. And typically on that machine there's one laptop running. So it's isolated. It's your environment. Production, however, we don't want to run on one machine. We want to have it high available. So we need to have some framework that allows us to do that. Docker Swarm, Kube, Mesos, Nomad, whatever. It's going to have multiple applications running there, and it's going to make sure that it keeps on running. The complexity between those two is much bigger. So that's just the application. So what about networking? Well, the developer is going to run it on localhost port, whatever he likes today. But from the operation point of view, we need to think about HTTPS, about signing those keys. Where do they come from? We need to think about how do we get traffic from somewhere into the right container? How do we do load balancing? How do we do service discovery? How do we do DNS, my favorite topic? Well, we can definitely choose one vendor lock-in which is going to solve that for us. Take the Google approach, take the Amazon approach, but if you have to do this, it's going to be more complex. We're back to the storage topic. Developer has one local disk. Couple of files Do they have real data? Well, I hope as of May 25th, they really don't have real data. But in production, we need to take care about actual customer data. We need to think about how to deal with backups, about how to do distributed storage. And the sad reality is that the most implementations I've seen these days fall back to NFS. What does NFS stand for again? Network failure system? No file system? Anybody? Who likes NFS in production? I don't. I thought we abandoned NFS a decade ago. But it's starting to become popular again because there's no solutions that are easy and fast to set up because we already have to deal with all the other topics. So a developer takes a random image from the internet because security has some local files. He takes a PHP container, some local files, that's the application. But when we go to production, we want to have CI infrastructure. We want to be able to build that container so we know it's secure. We want to know and trace where it's coming from. We want to push that to an image registry so other nodes can also download the same container and build from there. And we want to make sure that that container is reproducible. I saw there's somebody who proposed a talk on building containers. I hope that talk is actually going to explain all of that to you in 5 minutes. Should be enough, right? So, random image from the internet versus actually doing work and building something. Basically, we came to the point where developers now can say, hey, it works in my container, and pull in some random container. And we need to think about, well, it works in your container, but it needs to work in the whole system, distributed. We need to have monitoring in place. We need to have metrics in place. We need to have security in place. We need to have all of these topics covered. And we don't. We need to spend time fixing all of this. Because DevOps and running infrastructure is still all about collaboration. It's not about one golden tool that is going to fix our problems. It really is about overcoming that bigger pain, which is collaboration. I mean, Docker as a technology is really awesome. But from a culture point of view, it has set us back at least 5 years in culture adoption. Because we do get these developers now who just build a container and YOLO. Questions? Yeah, in the back.
So it's not really a question, but what I thought was so incredibly awesome a couple of weeks ago. I was sitting at the office writing some stuff in Go. I had a couple of web applications written in Go that I wanted to make Docker containers off so I could run it on Kubernetes. And I thought it was going to be like a really painstaking effort, but then I discovered that the Bazel build system, which is a build system that's originally written by Google and is now also open source, has integrated support for generating Docker images based on build targets. So what it allows you to do is, in addition to having a target in the Bazel build file saying like this is executable, you can also say, put this in a bare Docker image, so like a completely empty Docker image, put these files in this location in there and turn it into a tarball that you can load up in one go. And that makes stuff a lot smoother than I thought I'd ever had. So that solves some of the issues.
So you found one language where some problem is solved.
No, I found one build system for which it's solved.
You found one build system. Does it support more than Go?
Yeah, Java, Python, C++.
Okay. So you found a build system that solves a bunch of the problems. Every single vendor out there is pushing his own build system, which means most of the tools, most of the things that people have been doing for the past 5 years, they need to completely refactor to fit into that build system. Or does it run with everything out of the box? Is it completely no effort?
So I have to say that I've used Bazel a long time ago. Yeah, like when it wasn't open source yet. But the open source version, at least when you're writing Go code, it is pretty easy to switch. So for the reason that when you're writing code in Go, the source code is already placed in a way in the source tree that it can easily be derived how it needs to be built. So in the case of Go code, there's a tool called Gazelle that automatically generates Bazel build files. For other languages, I have no idea.
I mean, that's basically this slide. I mean, these are the Ruby guys trying to reinvent the wheel and trying to build a packaging system. These are the JavaScript guys. These are the Python guys. I mean, the joke is basically they use a package manager to build another package that has another bunch of dependencies, and they got 3, 4 within their own communities ways to build this. I'm not really deeply into the Go community, but it would surprise me if they're gonna solve it all at once. And that's only solving it for, I see Julien going like, nope, and he actually writes Go, so I kind of trust him on that.
Bazel and the Go team are both managed by the same company.
Yeah.
So ideally, I hope that there's only one solution.
But it's not really about a tool.
That's the whole point. It's not about the tool. The tool will, there's gonna be tools which are gonna fix that one use case which you have, which is in this case, hey, I'm writing Go and it solves the problem. But it's still about collaboration, because somebody has to set up that tool, and you cannot walk into an organization, hey, you got all these things in place already. Now we're gonna completely switch. You still need to get the ops folks to spin up that kube cluster. You still need to get the ops folks to understand how you're gonna monitor and measure that package. Or does your tool solve monitoring metrics too?
It's a build system.
Yeah, so you've solved one piece of the puzzle. A small piece, a crucial one, but a small one. And that's the whole point. It's not just about, it's about collaboration. It's about the whole ecosystem. Yeah.
I joined a company recently that had some gigantic Docker images based around Ruby with a full build system inside. How do you, we have syslog running inside it with tail, it's fabulous. How do you lead, educate, support, cajole a development team into the modern world?
Giving this talk, because it's not about them not, oh, they do care, but they've never been told. That's a fundamental problem I run into each time. Developers care, but they've never been told. And operations people have experienced the problems. Developers have never seen them. They've never touched production in a lot of environments. So they don't know. But once you sit next to them and you say, this, and or even the next step, you put them on call, then they realize the complexity of what they're dealing with. And then they're actually understanding that it takes a lot of more work than Docker pull YOLO and run 3 scripts and have it up and running on their machine.
Yes.
It's figuring out how to bridge that gap of developers wanting to get things out quickly, but at the same time realizing that speed doesn't give stability necessarily. So, yeah, I mean, sharing the pager is one way of achieving that, because developers feel the burn when they screw up. But I think it was, how do you get ops people to understand that speed can be necessary, because for a business, sometimes making that Friday night change is absolutely crucial because it closes the deal. And it's working out how you get those competing tugs on this problem, but in a way that's mutually beneficial.
It's not about the tools. I mean, I probably think somebody could do exactly this talk, but using Mongo as an example. Has the same pains, has the same issues, similar ones. That's the whole point. It's not about the tool, it is about collaboration. Docker is an easy victim, but there's other tools that are equally easy victims. And that's something we need to learn. Work together with the colleagues that allow you to push out a service fast and stable. And whether Docker is your tool, or Salt, or whatever, doesn't matter. It still is about collaboration. And that's the biggest message. Any more questions?
I'll bite. Now, so we built a system that basically compiles our operating system on demand for a specific application, a set of load balancers and firewalls. And we chose Docker basically because you need to ship a complete build system that's able to take some input and build an operating system out of it. And for us, sort of, that collaboration is hard because our development team needs to work with operations that are in other organizations. So of course, what sort of Docker was able to provide for us was a way to sort of abstract and package that whole build environment into a generic container that we then were able to ship out. Didn't really see an alternative way of us doing it. I agree with sort of most of what you're saying here. And of course, like the first time I built that container, I found it scary because there's like no components in there, and sort of downloads 666 modules down from Node through npm, and sort of it's a bit scary, but sort of yeah. I don't know how otherwise I could sort of address that without sort of.
There's two sides to that. I on the top of my head, don't see better alternatives onto shipping complex systems. I do want to discuss with you later how you actually ship the images and how you provide updates, because that to me is still a really complex system. But on the other hand, be on the receiving end of that stack. If you don't have any experience yet with the Kube ecosystem or with Docker in general, and you come out and say, here's our build environment and it requires you to run all of these, I can imagine at some point there's going to be a bunch of people there who are saying, no, we cannot do this.
Yeah, absolutely.
It's going to take time.
We maintain sort of a non-Dockerized version of the whole application. It's just that it's like the setup guide for that is
it's going to be complex.
And then like nobody has time for that, although.
Yeah. But complex system will remain complex. So you're going to have to bite in that bullet some way or another. Okay. That was it.